Okay, so this is the first lesson on angles, and we've got some sample problems here. The first question, question 1 on page 178, asks you to find an angle that is similar to the one that you see here. Well, we know that this is a right angle here, and since this beam cuts that angle, we know the whole angle is 90 degrees, so this part here is 90 degrees, and if this is 33.8, then the other part over here, we're going to subtract that from 90, and we get 56.2. Next one. Oops, I got these slightly out of order. Okay, let's try this one instead, excuse me. All right, so we're dealing with the sum of angles that add up to 90 degrees. So let's look at this one right here. I'm sorry, add up to 180 degrees. So let's take this part right here. So we see here is a straight line, and this angle right here is 138.6. So this other angle over here is going to be the difference because the total adds up to 180. So this must be the difference between those two, and so it'll be 41.4 degrees. Next one asks you for vertical angles. Now I can go back to that previous picture. Here we see a picture with vertical angles, and what we want to do is to find out what the size of those vertical angles. Now you'll notice each set is a different size, but I'm going to concentrate just on this very front one right here. This angle is 106 degrees. If that's true, this angle down here, since vertical angles are equal, this angle is 106. All right, and we could also say that since that angle is 106, this whole thing is 180, that would make this part over here 74 degrees. Next one. This is question number 2. Find the angles when you have two parallel lines cut by a transversal. There's a whole lot of lines going on in this picture, so I'm going to have to draw it so that you can see which ones I'm talking about being cut by a transversal. I've got this is one of the parallel lines. This is the other parallel line. And here is the transversal. So we are given one angle. This angle right here is 29 degrees. Okay, so we have to be able to figure out all the other angles. What the angle is down here. Okay, we have to figure out all those other angles. Well, in fact, it's not that hard because angles are either the same or supplementary when they are cut by a transversal. Right here we see an angle that's the same size, 29 degrees, and this angle out here is supplemental, so it'll be 151 degrees. This angle here is 151 degrees. We could have extended this out and then we would have had more angles. This angle would have been 151. This angle would have been 29. This angle would have been 29. This angle would have been 151. Next, same picture. We're going to concentrate on something just a little bit different though on this picture this time. We're going to talk about lengths. This goes with question number 3, find the distance. Okay, so here's our parallel lines once again. Remember, this only works if you've got 2 lines that are parallel and you've got distances, oh, I'm sorry, 3 parallel lines. Let's just pretend there was another bar down here. Yeah, let's pretend. No, that's not going to work. I thought I had 3 parallel lines here, but I don't. Well, on that number 6, or I'm sorry, that drawing 614, it kind of looks like this. Let's say that we had 3 parallel lines, and then we had 2 that were not necessarily the same, but we knew this distance was 5.05. This distance was 6.37. This distance was 4.28. Let's say we wanted to know what this distance over here was. So on our calculator, we would set up that proportion, where we would have 6.37 over 4.28 is 5.05 over question mark. So we're going to cross multiply and divide. All right, so just a second, I'm going to do it the other way around. We're going to cross multiply and divide. So we're going to take this times this divided by this. So on our calculator, we would just press it. Ooh, that's really nice and big. 5.05 times, so here's our cross multiplying part, 4.28 divided by 6.37 is 3.39. So this part right here is 3.39. Number 4. We've got some cross beams like this right here. Okay, I'm going to draw the picture.
Well, as defensive commanders are very effective in creating havoc. They led the league in the regular
Okay, here's our
week 39, but their secondary
straight angle that we know is 180 degrees. We want to divide that into 3 parts. This and this. So we've got those 2 angles and how they meet. This angle right here, this angle here, and this angle here. All right? And it tells us we're given some different measurements. Let's say that we are given this measurement right here is, I'm going to change colors here, 48 degrees. All right? And let's say that we're given this angle up here is 59 degrees. We want to know what's the size of this angle right here, and what's the size of this angle here. Well, let's start with the first part. All we would have to do is say that all 3 of those angles add up to 180. 180 minus 59 minus 48. 180 minus 59 is 121. Minus 48 is 73. So this angle is 73. I should have gotten out my calculator, shouldn't have I? And then add those two together, 73 and 48, and that should be 121. Okay, next. Number. That was number 4. Number 5, this picture. Okay, so it tells us that we've got this. Oops. Get my drawing tool. It tells us that this angle, I'm on number 5, which is figure 616. This angle right here, we know that looks about 63.4 degrees. Okay? It wants us to know, or it wants us to tell what this angle is, this angle is, this angle is, and this angle is, given that one fact. Well, this angle down here is exactly the same as this one, 63.4. These two angles are supplementary, so this must be 116.6. This angle is vertical to it, so it's 116.6. And this angle is vertical to that one, so it's 63.4. Next, number 6 is kind of like this problem. Right here we have some streets in Eau Claire. Here are our parallel lines. You have to have parallel lines for this to work. That's the only way this system works, is if these are parallel. This is parallel to this, is parallel to this. Okay? Those are parallel, and if that's true, we can figure out all of the sizes based on just the distances of two of these parallel lines. All right? So right here, from here to here is now I forgot what the distance was. 100. I just got it. 186 meters. This distance up here is 208 meters. From here to here is 203 meters. We want to know what this distance is. To do that, of course, we can use our calculator again and set it up as a ratio. 208 over 186 is something over 203. So let's cross multiply and divide. So we've got 203 times 208 divided by 186 is 227 meters. Number, that was 6. Okay. Next is the next assignment, or the next unit of the book, and we have to do numbers 1 through, oh, let me check. I might have forgotten what we had to do there. It was 1 through 8 on page 185. Okay, so question 1. All right, here we've got a triangle. I'm going to have to draw it so that you don't get confused about it. Let's assume that this goes straight, that this goes straight, and that this goes straight. All right? And then it tells us that this angle is 112 degrees. This angle is 23 degrees. We want to know two things. We want to know the inside angle over here, and we want to know the outside angle here. Well, there's two ways to figure out. One of them is that these two angles plus this angle here plus angle 3 add up to 180. So if we take 180 minus 112 minus 23, 180 minus 112 is 68 minus 23 is 45. So this angle is 45 degrees. If that's true, this angle is 135 degrees. Now, the reason that's true is that these two are supplementary, but it's also true that this angle is the sum of these two angles. That's another theorem from geometry. Next, find the area of this triangle. Okay, so we've got the triangle again. We're going to find the area knowing these two distances. This distance along this side of the triangle is 583 feet. This distance straight up and down is 296 feet. So on our calculator, area is 1/2 of the base times the height. So we get out our calculator. Area will be 1/2 of the base, which is 583, times the height, 296. Whoa, what did I do wrong? Go to air. Oh, times. I didn't put a time sign in there. And we get the area is 86,240, I think that said. 284 square feet. Now, it's important that we get the right number of sig figs there. Since these two have 3 sig figs, our answer will have 3 sig figs. So we would write our area as 86,300 square feet. Next one. Find the area of this triangle. What's interesting about, sorry about that. Here's number 3. To do it, I've got to kind of flip my triangle over. Okay, so here, here is the base of our triangle. Oops, sorry about that. I went too far. So what we need to do is to extend this side, here's the base, until we can get perpendicular to this corner here. So this angle is a right angle. This is then the height. This distance is 44 inches. This height is 53 inches. So the area of this triangle here, we can calculate from those two pieces of information. Let's see, fraction 1/2 times 44 times 53 is 100.166. We can only have 2 sig figs, so we would say it's 1200 square inches. Okay, that's all the assignment. If you have any questions, you can give me a buzz. This next triangle is that it has no right angles in it, and so we have to find the area using Hero's theorem, which is on page bottom of page 181. Okay, so here's how you do that one. Okay, Hero's theorem says you take the square root of the semi-perimeter times the difference between the semi-perimeter and each of the halves, or each of the sides. Okay, well, I'm going to draw the triangle. And then we will fill in the numbers. This distance along here is 58 feet. This distance is 97 feet. And this distance is 98 feet. So interestingly, it's almost a isosceles triangle. It's pretty close. These two angles are almost the same size. So the semi-perimeter is all the way around divided by 2. 97 plus 98 plus 58 divided by 2. That's the semi-perimeter. So we do that on our calculator. 97 plus 98 plus 58 divided by 2. And so the semi-perimeter is 126.5. Now, to find the area of that triangle, we multiply those four values together under the square root. So we have square root 126.5 times the semi-perimeter minus each of the three sides. So I'm going to start with the 97 times the semi-perimeter minus the second side times the semi-perimeter minus the third side. Oh, that was the second side, or the third side is 58. And we get an area of 2699 square feet. Since each of these has 2 sig figs, our answer will be 2700 square feet. Next, number which one was that we just did? That was number 4. Number 5, 2 similar triangles. Oops. 5, here's our 2 similar triangles. And I'm just going to pretend on this because obviously these are not similar triangles. They are congruent triangles because it's rafters in my attic. But I'm going to compare this triangle back here, this very farthest one, with this triangle here, one of the very front ones. In fact, it's so far forward you can just barely see the bottom part of it. But I do know that this side right here, it was built by Wicks, by the way, Wicks Lumber here in Eau Claire. All right, I do know the sizes. I know that for this triangle back here, it's 49.3 inches. This is 32.4 inches, and this is 38.7 inches. For the other triangle, the only measurement that I know is this bottom side is 136 inches. I just made those numbers up, by the way. But we should be able to figure out the other three sides, setting up a proportion. Our two proportions are 136, and then we've got the matching side for that is the bottom, 49.3, goes to 32. That'll give us this side over here. Let's call it A. B, that's this side over here, over 136, is 49.3 to 38.7. So if we do that math, let's start with A, cross multiply, 136 times 32 divided by 49.3 is S to D 88.3 if you round correctly. Okay, let's do the other one. 136 times 38.7 divided by 49.3, 3 sig figs in each answer, and so we get 107. So that's how you do that one, which is like number 5. Number 6, find the areas of right triangles. No, I'm sorry, find the hypotenuses of right triangles. Here's the first one that we're going to do. For this right triangle here, hypotenuse, leg, this distance is 408 feet, and this is 390 feet. It doesn't look like it, but they are a little bit off. And so if we take out our calculator, we can graph that and say the square root. So we have to press the square root key. Ooh, clear. Sorry about that. Square root key, parentheses, because we're going to have to take 390 squared plus 408 squared, close parentheses, is 564 feet. Next one is a little bit different, and that is we don't know one of the sides, but we do know the hypotenuse. Okay, so let's do this one right here. I think this is in Chippewa Falls. I'm not positive about that. I think it is, though. Okay, so here's our right angle up here. Remember, Pythagorean theorem only works with right triangles. This is 122 meters. This, the hypotenuse here, and I extended it out a little bit there because it actually is a little bit longer than that. This distance over here is 254 meters. We want to find this distance over here. If you're given the hypotenuse, subtract. So on our calculator, we're going to start with the square root key again. But we're going to take the hypotenuse squared and subtract the other leg squared. Close parentheses, and we get 223 meters. And if you notice, it is a little longer. It doesn't appear that way because of that, you know, the corner is cut off there. But that's how you do that one there also. I think, oh, we do have, I skipped one. I skipped number 3. I got to go back and do number 3. Okay.